Welcome to Your Texas Land, a place where we take a deep dive into all things related to land in Texas. I'm your host, John Kinsey, and I'm happy to have you join us today. In each episode, we explore topics that might affect you as a landowner, and today I'm joined by Mike Bodenchuk. Mike Bodenchuk is a professional wildlife biologist and manager with a long career in human-wildlife conflict management. He has worked for the state of New Mexico in the private sector and for 34 years for the U.S. Department of Agriculture Wildlife Services Program, including 17 years as the state director for the Cooperative Texas Wildlife Services Program. Today, we're going to talk about wildlife diseases and how they may impact private landowners and citizens of Texas. Thanks for joining us today, Mike.
I'm glad to be here. Thank you.
So let's start with a brief description of what Wildlife Services is and how it operates in regards to wildlife diseases in Texas.
The Federal Wildlife Services Program began over 100 years ago with demonstration projects right here in Texas. And they were geared mostly around protection of livestock from predators. Coyote control to protect sheep and goats largely was the start. But diseases factored into that early on. The Western programs in Utah, where I was the state director as well, was actually based on rabies suppression because people were getting bitten by rabid animals before there was a vaccine. That was a death sentence if you got rabies. In Texas, the Wildlife Services Program is a cooperative program between the state, counties, and private landowners and the federal government. And so each part of that brings funding to the table, brings responsibility. The state portion is run through Texas A&M AgriLife Extension Service, and the federal part through USDA, and the private sector through the Texas Wildlife Damage Management. So human-wildlife conflict is the responsibility in Texas of the Wildlife Services Program.
And like many issues related to wildlife in Texas, it's not always just a single entity that has their hands in it and that are operating within different aspects of wildlife management. There are, and related to disease, there are other entities that may be responding or may have their hands in a little bit, like Texas Parks and Wildlife Department or Texas Animal Health Commission. Can you explain how those entities work together?
Sure. At the federal level, there's even veterinary services, APHIS Veterinary Services, which is in the same large organization as Wildlife Services. They have the regulatory authority for like foreign animal diseases and for transportation across state lines. Texas Animal Health Commission has a responsibility in the state for state livestock protection from diseases. So they have regulatory authority as well on that. Texas Parks and Wildlife manages the wildlife, which includes wildlife diseases. So they have the responsibility for taking care of the wild animals. And of course, there's private landowners that are involved in this as well, and they are responsible for their particular piece of property. So everybody's got an interest in this and a potential responsibility in wildlife diseases.
And our audience typically is those private landowners. So can you tell me why private landowners in Texas should be concerned about wildlife diseases?
Well, there's a number of reasons. First, we're going to talk about some terms like zoonotic diseases. You may come in contact with a disease if you don't understand it, right? You shoot a skunk and your dog goes and grabs it. If the skunk may actually have rabies, and so there's a human health concern immediately for that landowner. There's also a wildlife concern. We saw an anthrax outbreak about 5 years ago in West Sutton County, and it devastated the native deer herds, and so the landowners are there. And then on some other diseases, whether it's livestock diseases or foreign animal diseases, the landowners are actually going to be the eyes and ears. USDA has exactly 2 wildlife biologists in wildlife services covering the entire state. We're not going to discover something. The landowners are the eyes and the ears for wildlife health out there. If they see sick animals, they see diseased animals or mortality events, they're the ones who are actually going to find it first and let the authorities know.
So you mentioned zoonotic diseases. Can you explain a little bit exactly what that means and what other types of diseases there are out there?
Sure. We're going to throw some terms around today about endemic diseases versus foreign animals, zoonotic. Zoonotic diseases are pathogens that are harbored in wildlife that can be passed on to humans. And a lot of the diseases we're going to talk about are zoonotic, and so there's a human health concern there. Endemic diseases are those diseases that we consider already here. Rabies is already here. Foreign animal diseases is the opposite of endemic. Foreign animal diseases are those that are out there in the world but are not in the U.S. So something like African swine fever is a foreign animal disease. USDA is doing surveillance for African swine fever, but it becomes a risk if it gets to the United States. And so there's issues surrounding foreign animal diseases that are different than endemic disease and management of those.
So we're not just battling the diseases that are currently here. We've got several knocking on our doorstep as well.
Absolutely, yeah.
So do all of these diseases result in mortality?
No, in fact, that's kind of the problem, right? Is that they are harbored in those populations. They can be spread from animal to animal. Some diseases do go straight to mortality. Rabies is fatal to that animal. But for the rabies virus to keep working, it gets passed from one to another, and the animals serve as the reservoir. Those diseases that cause immediate mortality are probably the highest risk, things like highly pathogenic avian influenza. But the diseases that don't cause mortality are the ones that are easiest to do the surveillance for. If you're out there looking for a disease that the animal had and got over, then you're looking for antibodies in their system. Just like when you and I get the flu, we feel sick on day one, we build that flu up, and after several days, our system creates enough antibodies to kill that virus off. You can measure those antibodies in our blood and tell when we had the disease, when we had the flu, and what kind of flu we actually had by the type of antibody. When we talk about surveillance for diseases, it's important to know whether we're looking for the pathogen itself, like E. coli, or whether we're looking for an antibody, which means the animal had the disease but got over it.
Do those antibodies typically persist over time?
They persist, and in some cases they degrade at a predictable schedule. So you can not only say, yes, there was, for example, plague in the environment. We'll talk about that in a little bit, but you can say there was plague in the environment 6 months ago because the antibodies that we discover in the carnivores that we're looking at have degraded to a certain level.
And so we started off saying that we're going to talk about wildlife diseases.
Yeah.
Then we started talking about zoonotic diseases. So that's how they can, jump to the human population. But how can some of these diseases impact livestock?
Well, some of them are absolutely passed on to livestock. Things like E. coli, for example, that might be out there in the environment. It's not going to kill the cow, but the cow that picks up enough E. coli in her system will perform poorly. She gets skinnier. She doesn't produce enough milk. She may abort her calf. Those kind of impacts that we would consider as production impacts. Some diseases become trade issue diseases, right? If you've got fever ticks in your nilgai and they get on your cattle, then your property is going to be quarantined until it gets cleaned up. And so there's localized issues, and then there's large-scale trade issues for livestock as well.
That's a great point to make, that it's not always our native wildlife species that Texas Parks and Wildlife Department has regulatory authority over that are spreading these diseases. Sometimes it's exotic animals that are free-ranging and much more difficult to control. Can you talk a little bit about how exotic animals may be spreading diseases across the state?
Sure. The classic example, and the one I'm most familiar with, is feral hogs, right? If you study feral hogs long enough, they start to look like a life support system for pathogens. They really just have a lot of cooties in them. And so the feral hogs are able to harbor about 30 different diseases that either affect livestock or people or both. And these complicate a lot of things. The brucella that feral hogs harbor, brucellosis is the disease, is a bacteria specific to pigs, Brucella suis. Brucellosis in cattle has been eradicated in the state of Texas, but the test for brucellosis in cattle will also detect if that cow was subjected to the brucella from a pig. And so if a cow tests positive, now the regulatory agencies, Texas Animal Health Commission, has to go out there and test all the cattle on the property to make sure that it's not the Brucella abortus that affects cattle, but it's the Brucella suis. It's a huge, huge risk out there, and pigs are just one example. Fever tick do get on nilgai, they get on red deer, and we've got free-ranging red deer and nilgai in the fever tick zone. So that's another problem that complicates the eradication. You can vacate the pasture with your cattle, but the ticks don't die out because they've got another host.
Sure. And you've mentioned several things, parasites, bacteria, viruses. Can you talk to us a little bit about how they show up differently in wildlife populations?
Sure. We're going to, again, talk about a number of things, but viruses are one category of pathogen. Viruses can mutate very quickly, and that's one of the risks that we have with viruses. And if they kill their host, they almost have to mutate in order for the virus to stay alive out there in the environment. Viruses, we talked about the influenza, flu virus. When an animal is exposed, it grows inside the animal. So day 0, the animal's exposed. Day 1 through 3, it's growing in there. The animal feels sicker. After day 3 or 4, it starts building up antibodies. And day 8 or 10, it stops shedding the virus and exposing other animals. Some viruses persist in that animal ongoing. Some viruses, that animal probably won't get sick again. Some viruses like rabies will kill them. Other pathogens include bacteria, and bacteria can be chronic infections, or it can be a one-time infection. They build up antibodies and they're over it, but they can be reinfected by that bacteria again. And there's a number of bacteria out there, some pretty bad ones. Anthrax is a bacteria, plague is a bacteria. And so bacteria are a different category. Interestingly, you can treat livestock that have a bacterial infection with antibiotics. Viruses, not so much. Viruses don't respond to antibiotics that much. A third category of pathogens that we probably talk about is parasites, and those go from protozoans that are microscopic, that are difficult to detect, all the way up to tapeworms and muscular worms like trichinella. Those kind of parasites can infect people and can infect livestock as well.
And are there differences in how those diseases are spread based on whether it's viral, bacterial?
Absolutely. Viruses are typically nose-to-nose. Bacteria is typically environmental. So each of those bacteria has developed their own evolutionary survival skills. You know, some of the bacteria can build a protein shield and lay dormant in the soil for years at a time until the environment's right. Other bacteria have to stay alive all the time. Viruses, like the rabies virus, has to have a live animal host. If it desiccates, the rabies virus actually dies off itself.
You mentioned wild pigs, and that's how you and I, our paths initially crossed. I was working with Texas Parks and Wildlife Department, and that put us in a lot of the same rooms. So you're probably gonna hear wild pigs a lot brought up in this conversation. There's some pretty nasty creatures. And you mentioned brucellosis. Now, there's 2 types of brucellosis. Is that correct?
There's more than that. There's militantous, but the ones that we're concerned about they have scientific names, just like animals. And so the scientific name of the bacteria that affects cattle, bison, and elk is Brucella abortus. It causes abortions in ruminant animals. The kind that affects pigs is Brucella suis, and that can cause abortions in pregnant females. It's spread when pigs breed. Many of our pigs have multiple paternity. Most of our pig litters have multiple paternity. So one boar breeding a sow and then another boar coming along afterwards. That's how that's spread. It's bacterial infection. But as I mentioned, the test for that is not specific to the species of Brucella. And so a cow that's exposed to Brucella suis will test positive for brucellosis and becomes a regulatory agent. We don't really know what the B. suis does in a cow. We have detected B. suis in raw milk where the pigs had access to the dairy. And the fact that it's being detected in the milk, not just in the cow, kind of indicates it's doing something inside that cow. And as we talked about the bacterias and the viruses evolving, we're really concerned that these things are getting together and evolving and might come up with a new strain or a new species of bacteria that would be harder to fight with antibiotics. So we watch these very closely.
Is that transmitted from cow to calf?
The Brucella abortus is absolutely transmitted from cow to calf. It's also in the tissue samples if the cow aborts that fetus, and it can be passed on through milk as well to a healthy born calf.
Continue the trend on cattle. What can you tell us about bovine tuberculosis?
Bovine TB is largely a disease of cattle, but it has spilled over into wildlife in several occasions. It spills over into pigs. Wherever pigs are exposed to it, there's a real neat study in New Zealand where bovine TB, the bacteria that causes that, is endemic in brush-tailed possums, which are not native to New Zealand. So again, you've got an invasive species with an invasive disease. They turned some pigs loose with radio collars, and a year later they went back and got them, and 100% of the pigs that they got their hands on had bovine TB. Once it becomes entrenched, it can be a real problem.
Has there been any documentation of bovine tuberculosis in deer species here in Texas?
No, not yet. We have had, in my 17 years as a state director here, I can recall 4 cases of bovine TB in cattle, and in each case we went out and did surveillance to see if it had spilled over into the wildlife population. So if there's feral hogs in that area, that's the first thing I want to get my hands on because they're such a good surveillance tool. We've also looked at deer where it was entrenched for quite a little period of time, and we have not found it spilling over into the wildlife populations yet.
And so for the audience, just to let y'all know, sometimes neat and interesting studies in the world of wildlife research is also synonymous for scary. And to that note, would you explain to us a little bit about what anthrax looks like in the state of Texas and some of the interesting things that have been discovered in recent years in regards to anthrax and feral pigs?
Yeah, so anthrax is an endemic disease. We have naturally occurring anthrax in Texas. We used to call it a triangle. It's starting to look like a 5 or 6-sided shape out there in Sutton County, Valverde County. It's going up towards Tom Green now. But in that part of Texas, the bacteria is in the soil, and the anthrax bacteria can form, I'll call it a spore. It's probably not technically a spore, but it develops a protein shield around it and can survive in the soil for years at a time. When you get the right environmental conditions, typically wet conditions followed by hot conditions, that can become infective, and animals that come in contact with that get it. It is absolutely devastating to a deer herd. Livestock producers can vaccinate sheep, goat, cattle, horses against anthrax. It is an expensive process, and like we said, it's only occasionally that it comes up in the environment, so you would be vaccinating every year not knowing whether that's doing you any good or not. So typically we don't see a lot of vaccinations till there's an outbreak. You can't practically vaccinate deer at this point, so you could dart one at a time, but that's not going to do anything at the population level. We felt like there was a connection between feral hogs and anthrax for a number of years, and when that Sutton County, the last outbreak in West Sutton County occurred, we were able to go out there and sample pigs at the time, and we found that every hog that we sampled had been exposed to anthrax, had developed antibodies to anthrax, but it did not kill the pig like it killed the deer, like it killed the cattle and the horses. And so that was the first interesting step that we had in discovering anthrax in pigs. When we do surveillance around the state, we pull a blood sample, we spin it down and put the serum in there. We look for certain pathogens in that serum, but we've always archived a sample of that serum as well. And so following that first discovery that it didn't kill the pigs, but they were converting antibodies, we went ahead and looked in our archive bank and took the samples to the same lab, and we sent them as blind samples. So there was samples from pigs in counties that had anthrax and samples from pigs in counties that have never had anthrax, and the lab didn't know which was which. The lab pegged them 100% of the time. They got the right anthrax samples there. So pigs are now a good surveillance tool for anthrax, even in post hoc after the event. The third example was even more interesting to me, and I got permission to take some young feral hogs to Colorado State University up at Fort Collins, put them in a biosecure facility, and we gave them anthrax. And if you ever want to get the attention of the Department of Homeland Security, tell them you want to give some pigs some anthrax and see how fast your phone rings. It took a couple years to get permission to get that study done. And not only did all of the pigs that were given anthrax seroconvert, but they were able to recover the bacteria from nasal swabs in some of the pigs. So that tells us that out in that area, feral hogs are not only exposed to it, but they're amplifying the bacteria and they're spreading the bacteria through their movements. If you know anything about Sutton County, most of the water is in water troughs. It comes out of windmills and pipelines and water troughs, and a pig sticks her nose in that water trough, contaminates the water, and then a deer comes along or a cow comes along. And so pigs might also be mechanical vectors. They root up the soil and they expose that dirt with bacteria in it. Deer may feed in those rooted areas more frequently because it grows back in forbs. So there's a number of connections there, but we do know that pigs amplify anthrax and it doesn't kill them.
So would there also be concerns around, in Texas, we use spin cast bait feeders frequently for different reasons, but white-tailed deer hunting predominantly. You mentioned nose-to-nose contact. Is there any threat around those feeding sources, those shared feeding sources where we often see pigs and white-tailed deer or different native species feeding at the same place?
Yeah, spin cast feeder is going to scatter that grain out there. The pigs are going to put their nose down every time they pick up a piece of that. They're going to leave some of that bacteria in the soil, and so you're concentrating that. If I had an anthrax outbreak, you don't know it until it happens, but I would shut that feeder off, and I'd consider moving it in future years because it's not going to be safe for the deer to stick their nose down on that same soil the next time you get the right environmental conditions.
And so the last feral pig specific question for you, and I don't want to go down the rabbit hole of this one. And we'll probably have a separate podcast on chronic wasting disease at some point. But fairly recently, it has been identified that wild pigs may be able to carry chronic wasting disease. Is that correct?
Yeah. So again, we have CWD on our border. We have CWD within our state. Our Wildlife Services Program was starting a feral hog control program in the Canadian River and country that we had never worked in before. And so it was our interest to actually see if there were any prions in that area associated with the pigs. We knew that CWD prions were coming in from New Mexico. They're infected on their side. And my guess was that we were going to go in there and sample of 100 pigs and come up with no prions. We did send those samples to a laboratory, and they did recover prions from the feral hogs from their lymph nodes. The fact that those prions were concentrated in the lymph nodes and not in the brain tissue shows that it's doing something in the pig, right? The pig's encountering prions, perhaps feeding on a deer that died from CWD, however they encounter that. But they're sequestering those in their immune system, which tells me that there's something going on in the pig. Interestingly, the researchers that we sent those samples to were able to recover those prions. They gave them to transgenic mice that replicate how deer behave, and the mice came down with neurological disorders similar to CWD. So we know not only that the pigs are picking them up, but they're infective prions. When that pig dies, that prion's going to be wherever that pig dies and melts down into the soil. We don't know anything more about prions in pigs. We don't know if they shed them the same way that a deer does. We don't know that if a pig lives long enough, whether it'll cause a disease the same way it does in deer. We haven't seen that kind of impact, but pigs typically don't live but 4 or 5 years. So,
Sure.
But we do know that they're amplifying, or maybe amplifying. They're certainly moving them around the landscape, and they are able to move infected ones. We actually found pigs with CWD prions outside of the CWD zone that Parks and Wildlife had established for that area based on deer surveillance. Mm-hmm. So whether the pigs moved or whether the prions were moving with deer and just hadn't been detected in deer yet, I don't know, but the pigs were picking them up, and that's fairly alarming when you start looking at movement of feral hogs, right?
Sure. That's another reason to be mad at pigs.
Anybody who kills a pig is a friend of mine.
All right, we'll shift gears a little bit here. So it's been in the news quite a bit over the past year or so, but highly pathogenic avian influenza in wild birds, where does that stand today? Can you give us an update on what's going on with that?
Yeah, so avian influenza is just what it sounds like. It's bird flu. Mm-hmm. And highly pathogenic is how we categorize these types. Quite literally, they take the virus that causes that influenza and put it in duck embryos, and if it kills 80% or more of the embryos, it's highly pathogenic. Birds come in contact with flu viruses everywhere, just like people do. And if those viruses don't cause any mortality, don't cause any production effects, nobody's ever going to go looking for it. The strain that's circulating right now, and this is about the 4th highly pathogenic avian influenza in my career, the strain that's circulating right now is fatal to a lot of birds and not to others. So some birds, like raptors, very, very susceptible to highly pathogenic avian influenza. We were working with some people that were trapping peregrine falcons, and they said, hey, we can sample these. And we said, no, thank you. If they have it, they're dead. And if they're alive, they don't have it. Sampling them is if you've got a live bird in your hand, he doesn't have the disease. It's that quick. It is devastating to the poultry industry. And chickens have been depopulated. The reason eggs are so expensive, the reason your Thanksgiving turkey costs more is because whole farms are having to be depopulated when this virus gets in there. And we believe it's being spread by wild birds. Some wild birds are not very susceptible. The ones we are doing the surveillance in are waterfowl, and in particular puddle ducks. We'll sample other ducks as well, but mallards, gadwalls, those kind of dabbling ducks are the ones that can get the disease, don't die from it, and can move it around the landscape. So when ducks come in to Texas, we sample a couple thousand of them in different watersheds to see if the disease is there and how it's moving across the watershed. And it's kind of interesting because you'll see it in the Panhandle in September in the teal samples, and in October when they start their High Plains mallard season, and then you see it in December down on the coast. Well, those may be the same ducks. I mean, it's the same push of waterfowl as they migrate south. Other species, snow geese, for example, are highly susceptible to it. And in the Dakotas, one spring season, they had geese falling out of the air. They were migrating and they died in the air and fell down and hit the ground. It was really remarkable the amount of mortality that they were seeing in snow geese. So it is a great concern, because we not only have wild birds out there, but we have backyard birds, right? Every urban duck pond has got ducks on it that can get that disease. And then somebody walks through the duck droppings, goes home and feeds their chickens, and now we've got an outbreak in poultry. So that's a disease that's affecting trade in poultry, that's affecting production in poultry, and it is fatal to a lot of the birds that we care about.
That might be a good place to talk about the difference between prevalence and detection rate.
Yeah, sure. There's prevalence, true prevalence out there in the environment is the percentage of animals that are actually have the disease or have been exposed to the disease. It depends on what you're looking for. Detection rate is a whole different thing, and the fact that we can detect high-path avian influenza in mallards that might be shot isn't surprising. It's just what percentage of them we're detecting it in. Remember, we're detecting it in birds that were hunter harvested. We're not shooting them. We're not trying to sample 100% of the population. So it's not a true prevalence because we don't know. These might have been the slow ones and the only ones that hunters could hit. But we're actually talking about sample size and comparing it to another sample size instead of actually a percentage of the population. We do the same thing with pigs. We look for certain diseases in pigs. I'm not looking for those diseases in the small pigs. They probably haven't been alive long enough to be exposed to that. So it's not true prevalence. It's not 13% of the population. It's 13% of the samples, and that's a big difference.
Sure. I can't remember the last time I took my shotgun out of the gun safe, so I promise you're sampling the slowest ones whenever you come to my hunter harvest. I think we've covered a lot of different types of diseases, but I don't think we've really hit much on parasites yet. Could you talk to us about maybe fever ticks to start with?
Sure. Fever ticks are named that they're a soft tick. They're a small, head of the pin, a little bit bigger sized, soft-bodied tick with small mouth parts that were common across the United States. If you read the history, that was part of the problem with the cattle drives. When Texas cattle went north, they were dropping ticks on the landscape, and that was killing bison, that was killing cattle in Nebraska. And so they went back a long time. We eradicated that tick. And the tick isn't the problem. The tick actually has a parasite in it that causes a fatal fever in bovines. And so that's the real problem. That tick feeding on a cow could pass on a disease, babesiosis, to the cow. So most people are familiar with the kind of ticks that get on your dog or get on deer, the Lone Star tick or something like that. And those ticks go through a 3-year life cycle, 3 stages. Those little bitty black pepper-sized seed ticks that we talk about are year 1 ticks. They hatch, they live in the grass, they get 1 blood meal, and they go hide in the duff to overwinter. The next year, they are the regular tick that you see crawling around, and we come in contact every time I go turkey hunting. And those are 2-year-old ticks. That's a second instar is what they call it. And those ticks will bite multiple hosts. The 3rd year tick, they get a single blood meal. They swell up, they lay eggs, and they drop to the ground. Those eggs hatch. With fever ticks, they go through 3 instars also, but that whole time period is only 18 days. And so they will attach to a single host, go through 1 molt, become a second instar, then go to a 3rd instar, then drop off. When that female tick lays her eggs, those hatched eggs can go 9 months without a blood meal before they die. So when we eradicated the disease, and this is cool science to me, when they eradicated the disease, they did it one of 2 ways. You either vacated a pasture for 12 months, and then there was no blood meal out there. The ticks that hatched all died. or you dipped your cattle every 14 days. And how many of these ranches have old dipping vats on them, little concrete troughs that they would dip? They round up the cattle, dip them every 14 days, and kill those ticks before they could mature, and then turn the cattle out to gather up more ticks. They actually use the cattle like a sponge to clear the pasture of ticks, and then they dip them again before they could do that. Well, back when they did that, we didn't have the white-tailed deer populations that we have today. We didn't have the nilgai. We didn't have alternative hosts. And that's what's complicating some of the management now is the other animals that are out there that are hosting those ticks that can move the ticks. Nilgai have a huge home range. They can move the ticks around the landscape and drop them in a new place. It just takes one gravid female, one female that's going to lay eggs to start a new population on a new ranch.
It's much more difficult to dip or treat those free-ranging wild animals. But they're working on some treatments for nilgai in South Texas. Are you familiar with what they're...
There's a lot of research going on to that, whether that's, nilgai have marked their territories with large dung piles. And so if we could get a spray system up there that would spray an insecticide over that when it detects a nilgai, some real smart AI technology that says, oh, that's a cow, don't spray. Oh, that's a nilgai, we're going to spray. Where nilgai go under fences, they could have rub poles that would put insecticides out there. And you can use treated corn to treat deer, but that corn won't allow people to, the chemical won't allow people to eat that deer. And so we got to withdraw from that 30 days before deer season.
Sure.
You can't feed that year round. And so there's all kinds of ways that people are looking at trying to beat that tick back. We had it eradicated in the U.S., and there's been a permanent tick zone along the river, but there's these outbreaks that are basically wildlife vectored outbreaks that keep happening across the state.
Are those typically in South Texas?
They have South Texas origins, but sometimes it's somebody that'll move a nilgai from South Texas to an exotic ranch. Sometimes it's somebody moves a cow that was bought outside the quarantine zone. If somebody buys a cow inside the quarantine zone, they're going to dip that cow before they can move it. But there may be a cow outside the quarantine zone that gets sold at an auction barn, goes to a new ranch, and that becomes the problem then.
The unintended consequences of anthropogenic movement of animals.
Yeah.
Absolutely.
Yeah.
There's another parasite that's been in the news here recently that we once had eradicated as well, but now we're seeing a new world screwworm pop up. It's pretty prevalent in Mexico at the moment. Can you tell us a little bit about that?
Sure, and that's part of the reason we didn't have a lot of deer in the 40s, right? We also had screwworms out here, and screwworms are flies that will lay eggs in an open wound on an animal. Those maggots, the larval fly, will actually feed on live tissue, and they look like a screw. They burrow into the animal, and they cause a lot of pain, illness in that animal. Okay. And when we had screwworms in Texas, people had to ride their livestock all the time and doctor their animals every week to keep those screwworms from killing their animals. Again, cool science. Screwworms the fly only lives for so long, and they only mate once in their lifetime. So the way that we got rid of them was to irradiate male flies and drop sterile male flies across the landscape, literally out of airplanes, little crates that were dropped out of the airplane that would release these flies. They'd mate with the females. The females would lay inactive eggs, and we eradicated screwworms across the U.S. We pushed that eradication effort down through Mexico, down through Central America, and got to, I'm going to say, the canal zone, the very narrowest part of Panama, where we kept a border there where we dropped sterile male flies for years. But we didn't have to do all of Texas. We just had to do Panama. Screwworms are still prevalent in South America, and they've come back up through Central America and are now in Mexico, in Oaxaca, which is down south. And we're concerned about it because that didn't happen overnight. That didn't happen with a single animal being moved. That is the spread. And so USDA is gearing up for a lot more sterile fly drops. They're building a facility down there in the valley. The airplanes are held down there in the valley. Texas Animal Health Commission and the Texas Department of Agriculture are joining in that in some surveillance efforts for screwworms. We want to make sure that they don't get here.
To that note, diseases that aren't quite here yet, but are knocking on our doorstep. African swine fever, you mentioned it earlier. Where is it in relation to the United States? What is the likelihood of having African swine fever detected in the United States, and what are we trying to do about it?
African swine fever is a virus that is endemic in sub-Saharan Africa. So warthogs, bush pigs, giant forest hogs, all have been exposed to it. They evolved with it, and they're immune to it. When it escaped Africa, when the virus gets elsewhere, it causes mortality in European wild boar. It causes mortality in domestic pigs, high rates of mortality. And it's escaped Africa several times. There were outbreaks in Spain that were beat back in domestic animals through control of feral hogs and depopulation of domestics. Sicily has had a recurring episode of it, but probably starting 10 years ago, 15 years ago, it became entrenched in Western Russia, has now spread across the European Union. And the virus is environmentally stable. What we find is that it's moved mostly by people. Somebody moving a sausage sandwich and throwing it away, or feeding the leftovers to their domestic hog, is how that gets pushed around the landscape. In Germany, they had the virus spread about 50 miles in 9 months, just environmentally, from pig to pig, wild boar to wild boar, or with biting flies biting the wild boar. That's another way it can be spread. But it doesn't move rapidly across the landscape that way. If you know what the Caribbean looks like, the big island of Cuba is Long Island. The next big island to the east is Hispaniola, and there's two countries on Hispaniola. There's Haiti and the Dominican Republic. Two countries share one island. We know that it's in the Dominican Republic, and how it got there is absolutely got to be human mediated, right? Somebody took jerky or something from an infected area to the Dominican Republic. The next island to the east is Puerto Rico. Puerto Rico is a U.S. territory, and there is no quarantine. There is no stopping of product that goes from the U.S., from Puerto Rico to the U.S. So we are concerned about it moving around the landscape of the Caribbean and finding its way here. African swine fever also worked its way through Asia, and China lost a lot of their domestic swine industry. Vietnam had a big outbreak in domestic pork, and Australia was able to actually find the virus in Chinese-based pork products that were exported to, which fascinates me. This disease kills a pig within 72 hours. How could it be in the meat unless they're killing sick pigs? I don't understand how that happened, but we are concerned about imports of meat from infected countries. And in fact, that's the biggest problem, is not that it's going to kill a lot of domestic pigs. There's great biosecurity around domestic pork facilities. Our pork industry is very, very safe. But it becomes a trade issue immediately. The first case that shows up in the U.S. will close off trade markets for U.S. pork products. And so USDA is doing surveillance among feral swine. We've actually mapped where people from the Caribbean come, and 3 of the 5 states actually have feral swine populations: Florida, Georgia, and Texas. So we're looking in those states in feral swine populations, trying to see if it's there, trying to be the first discovery if there is an impact. And we're also looking along the U.S.-Mexico border. Sometimes that border is pretty porous, and people coming across with a sandwich from Africa could be the source of that. If that gets dumped at a campsite and a pig picks it up, we could have a problem. So we're doing the surveillance. We actually expect to find nothing, but there is a lot of talk around that. There's a lot of planning around that, and if it shows up, we have an action plan associated with that.
So even if it shows up in the feral pig population, you've got an immediate impact to the domestic pork industry?
Absolutely. Germany lost all of their markets with a single European wild boar. It was not in their domestic industry, but they lost their Chinese markets overnight with a single wild pig.
And is that the same situation with foot and mouth disease? We've eradicated foot and mouth disease in the United States, but given the population of feral pigs and the fact that, feral pigs don't really adhere to political borders and whatnot, potential impact for feral pigs to be infected with foot and mouth disease would have a similar impact to the pork industry?
Yes, and not just the pork industry. Foot and mouth diseases also can affect cattle and can affect wildlife. And so African swine fever is pretty much a disease of pigs, but foot and mouth disease is a disease of things that have a hoof. When domestic pigs get foot and mouth disease, the symptoms are very, very classic. They get lesions in their mouth, they get the soreness, they come off feed because it hurts to eat. But also their front hooves become very sensitive, and they actually will stand on their front knees. The symptoms so classic, they teach it in veterinary school. We took feral hogs to a research facility offshore in New York, where you can do foreign animal disease stuff. And we gave feral hogs foot and mouth disease, and they did not get down on their knees. They got some lesions in their mouth, but they did not come off feed. That we talk about hybrid vigor in livestock, hybrid vigor in feral hogs. They'll spread foot and mouth disease faster than livestock will, just because they're not as susceptible to the symptoms. And so they're going to keep moving around, they're going to keep feeding. And so foot and mouth disease in feral hogs is a movie of the week nightmare, that we're concerned about. We do look for that as one of the regular diseases we screen for in feral hogs.
So we should be paying attention to what the potential symptoms of some of these diseases are, and if we see them as a biologist or even a private landowner, what is the best course of action if we suspect that we might have encountered any animal with any type of disease? It's a fine line between an animal that's just old or maybe dying on its own, or something that's got a disease, right? Some of these diseases have very, very classic symptoms. When swine get African swine fever, they develop a fever. They huddle together to stay warm, and they die in a pile, essentially. If somebody finds a pile of dead pigs, that's cause for concern. If somebody finds one dead pig here and another one 100 yards away and another one 100 yards away, that's a symptom of aerial gunning. And so that's not the kind of thing that needs to be called in unless you didn't have permission to aerial gun. But that's not a disease, right? We're looking for unexplained, sick animals. And landowners or resource managers that come across those need to be aware of what some of those things are. Now that feral hog toxicant kaput is licensed in Texas, you may find dead pigs on your landscape, but again, they're going to have that blue dye in their fat. You can see that a long way off when the vultures start feeding on them. And that is an indication that it's not a disease-related mortality, but mortality, morbidity events where animals are sick and moving around, those probably need to be reported as well. And we've got robust surveillance systems in place for domestic animals, livestock. It becomes a little more difficult when we talk about things like screwworms or foot and mouth disease, where it's not just a single animal that's impacted, or it's not just the domestic livestock industry that's impacted, but they're prevalent in wildlife. Are there any monitoring efforts in wildlife populations to detect some of these diseases?
Sure. Some of the other diseases we haven't talked about, like, for example, plague. We collect blood samples from carnivores when we remove those in the course of protecting livestock, and those samples are available to test for plague. Plague is one of those things that has antibodies that degrade over time. And when we detect plague in one of those, when we detect leptospirosis in one of those, we actually notify local health providers because, frankly, these diseases, when they get around people, are pretty rare. And doctors aren't looking for them in the course of a differential diagnosis. Somebody comes in with flu-like symptoms, they give them NyQuil and send them home. Well, that might have been plague. And so when we know that it's circulating out there in the wildlife, we can notify the health officials that would actually include that in their diagnosis then. But there's only so many government officials, right? We need landowners, we need resource managers out there that can help be the eyes and ears to help people understand this. Sometimes an aborted calf is just an aborted calf, and sometimes it's a leptospirosis outbreak.
Sure. What is the best course of action for a citizen or private landowner that suspects that they may have encountered an animal with a disease?
For most of the endemic diseases, for an anthrax outbreak or anything else, they need to work with their local veterinarian. If they think that it might be a foreign animal disease, then they need to contact Texas Parks and Wildlife or Wildlife Services Program, Texas Animal Health Commission. And the agencies work together to try and get a response team out there. Somebody will go out there and look at the samples. There's consequences to even looking, right? If you suspect that there's African swine fever, we want to know, but we don't want to broadcast, hey, there's African swine fever, because that affects prices on the of commodities overnight. So there's a real strict, rigid protocols on what samples get sent if we suspect that it's a swine fever case. We've had a couple of those where we respond to a mortality event, only to find out that herd of pigs actually got hit by a car and they wandered over there and died together. It wasn't a disease, but we didn't want to send the wrong message that it might be, because that affects the price of the commodities.
And so the area of wildlife diseases might not be the best place for citizen science.
Well, it's citizen eyes and ears, yes.
Exactly.
Absolutely.
From a monitoring perspective, but let's not go get our hands dirty and try to collect our own samples.
Absolutely. There's other diseases too. Botulism, for example, is a very common summer disease in waterfowl in the Panhandle. When you got water that doesn't move, it develops a bacteria that kills those ducks. And the worst thing I'd want to see is a homeowner out there without a pair of gloves on picking up dead ducks. That's going to expose that person to the botulism as well. So please be careful, but notify folks.
Sure. So what's one piece of advice that you would give a landowner when it comes to managing or preparing for wildlife diseases?
You know, we spend a lot of time talking about wildlife management tools, habitat management tools, and all the rest, and we don't spend much time talking about diseases. They need to know that they're out there. They need to know the ones that might affect them. If you're in North Texas, I don't think I'd spend a lot of time on anthrax, but I would, if you're in the Panhandle, be concerned about plague, because that is a bacterial disease that will affect prairie dogs and cause die-offs. It is zoonotic, and people die from it. So know the diseases that might be of concern in your area. If you're talking about feral hogs, I just got to tell everybody, I don't need them anymore, but if you're going to handle a feral hog, wear latex gloves. We've got so many pathogens in there that you can actually be just transmitted by touching the outside skin. So protect yourself, know your personal protection equipment, make sure that you don't contaminate surfaces if you're going to clean one of them. Know those kind of things. There are high path AI recommendations for waterfowl hunters that are out there by the CDC. So there's a lot of that information that's out there.
Sure. If you're going to eat feral pigs, let's not have a medium rare pork loin.
Oh, no. That we talked about parasites, but you've got to cook that meat to 60 degrees internal temperature, or freeze it for 28 days or more to get rid of toxoplasmosis, which is a protozoan, to get rid of trichinella, which is a muscle worm. You don't want to be ingesting that and having that live in your system.
How can listeners stay informed about outbreaks and changing surveillance in their areas?
Well, again, the number of resources, and that's the beauty is that everybody works together. The problem is that everybody's got their own websites, right? So Texas Animal Health Commission has got websites with a lot of things on there. You can log on there and look at their news releases. Parks and Wildlife has it primarily around a handful of diseases that are hot button issues right now. Anthrax will be Animal Health Commission issue. They're talking about it from the livestock perspective, but if there's an anthrax outbreak, you got to be worried about it from the wildlife standpoint as well. And then your extension agents can put people in touch with Wildlife Services, local trappers, or with the district offices if they've got questions.
Absolutely. Mike, is there anything that I missed or anything that you think we should circle back on and catch at this point?
No, I think, again, I appreciate the landowners that are interested in this topic and that can serve as the eyes and ears for the agencies out there. It's good to think about this when you talk about wildlife management.
And that's a wrap for today's episode of Your Texas Land. We hope you enjoyed hearing more from Mike and I all around wildlife diseases and how they may impact citizens of Texas, private landowners, and the agricultural industry. Thank you, Mike, for joining us today.
Thank you.
Until next time, keep being an advocate for Texas land. Thanks for listening.